Hello friends, and welcome to the tutorial on symbolics with Sage. At the end of this tutorial, you will be able to define symbolic expressions in Sage, use built-in constants and functions, perform integration differentiation using Sage, define matrices, define symbolic functions simply and solve symbolic expressions and the functions. Before beginning this tutorial, we would suggest you to complete the tutorial on getting started with Sage Notebook. In addition to a lot of other things, Sage can do symbolic math, and we shall start with defining symbolic expressions in Sage. Have your Sage notebook opened. If not, pause the video and start your Sage notebook. On the Sage notebook, type sin y. Then click Shift Enter. It raises name error saying that y is not defined. We need to declare y as a symbol. We do it using the var function. So type var within brackets and single quotes y. Now if you type sin y, simply returns the expression. So type sin y. Now Sage treats sin y as a symbolic expression. We can use this to do symbolic math using Sage's built-in constants and expressions. Let us try out a few examples. So type var within brackets in single quotes x comma alpha comma y comma beta. Then in next line you can type x caret 2 by alpha caret 2 plus y caret 2 by beta caret 2, that is x square by alpha square plus y square by beta square. We have defined four variables x comma y comma alpha and beta, and have defined a symbolic expression using them. Here is an expression in theta, so you can type var within brackets and single quotes theta, theta. Then type sin within brackets theta multiplied by sin within brackets theta plus cos within brackets theta multiplied by cos within brackets theta. Now that you know how to define symbolic expressions in Sage, here is an exercise. So pause the video here and try out the following exercise and resume the video. Define following expressions as symbolic expressions in Sage. There is x square plus y square, and next one is y square minus 4ax. The solution is on your screen. Here is var within brackets x comma y, then x square plus y square. That is x caret 2 plus y caret 2. Then next is var a comma x comma y, then y caret 2 minus 4 into a into x. Sage also provides built-in constants which are commonly used in mathematics. For instance, pi, e, infinity. The functions n gives the numerical values of all these constants. So you can type n within brackets pi, then n within brackets e, then n, then 0, 0. That is OO. If you look into the documentation of function n by doing n tab, you will see what all arguments it takes and what it returns. So you can type n, then hit tab. It will be very helpful if you look at the documentation of all functions introduced in the course of the script. Also, we can define the number of digits we wish to have in the constant. For this, we have to pass an argument, digits. So, you can type n within brackets pi comma space digits is equal to 10. Now Apart from the constant, Sage also has a lot of built-in functions like sine, cos, log, factorial, gamma, exp, then arctan, which stands for arctangent. So let us try out some out of these in the Sage notebook. So you can type sine within brackets pi by 2, then arctan OO, then log within brackets so when you type arctan, there was an error in arc, so you have to type arctan, then type log e comma e. So now pause the video here and try out the following exercise and resume the video. First one, find the values of the following constants up to 6 digits precision. So first option is pi by 2, pi square, then Euler gamma square, Euler underscore gamma square, and next one is find the value of the following. First one sine pi by 4, next one is ln 23. The solutions are on your screen. That is n into pi square, n within brackets pi square comma digits is equal to 6, and pi square is written as pi caret 2. Next one is sine n within brackets sine into within brackets pi by 4, and the third one is n in within brackets log into 23 comma e. Given that we have defined variables like x, y, etc., we can define an arbitrary function with desired name in the following way. So you can type var within brackets within single quotes x, and then next line function within brackets in single quotes f, comma, then x. Here f is the same of the function and x is the independent variable. Now we can define f of x. That is f of x within brackets x is equal to x by 2 plus sine x. Evaluating this function f for the value x is equal to pi returns pi by 2. So type f and within brackets pi, you will get the answer there 1 by 2 into pi. We can also define functions that are not continuous but define piecewise. Let us define a function which is a parabola between 0 to 1 and a constant from 1 to 2. We shall use the function piecewise, which returns a piecewise function from a list of pairs, and for that you can type the following: var within brackets in single quote x, then h of x is equal to x caret 2, then g of x is equal to 1. Then next line you can type f is equal to piecewise within brackets 0 comma 1, then comma h in another bracket x, then in next bracket square brackets it is 1 comma 2, then comma g of x comma x, then type f. We can also define functions convergent series and other series. We first define a function f of n in the way discussed before. So you can type var within brackets n in single quotes, then type function within brackets f comma n, then to sum the function for a range of discrete values of n, we use the Sage function sum. So for a convergent series, f of n is equal to 1 by n square. We can say by typing var within bracket single colon n, the next line function f comma n, then f of n is equal to 1 by n caret 2. Then sum within brackets f of n comma n comma 1 comma oo. That is f of n comma n comma 1 comma oo. Let us now try another series. You can type f of n is equal to within brackets minus n raised to, that is caret within brackets n minus 1 multiplied by 1 by 2 multiplied by n minus 1. Next line you can type sum within brackets f of n comma 1 comma oo. This series converges to pi by 4. So pause the video here and try out the following exercise and resume the video. Define the piecewise function f of x is equal to 3x plus 2 when x is in the closed interval 0 to 4, and f of x 4x raised to 2, that is 4x square, between 4 to 6. Then next one, sum of 1 by n square minus 1, where n ranges from 1 to infinity. The solution is on your screen. VAR within bracket x, then h of x is equal to 3x plus 2, then g of x is equal to 4 star x caret 2, then f is equal to piecewise within bracket in square bracket 0 comma 4 comma h of x, then comma in another square bracket 4 comma 6 comma g of x, and then comma x. Then type f. Then next step you have to type VAR within bracket single quotes n, then f is equal to 1 by n caret 2 minus 1, then sum, then brackets f of n comma n comma 1 comma oo. Moving on, let us see how to perform simple calculus operations using Sage. For example, let's try an expression first. So type DIFF, then within brackets x star star 2 plus sine of x comma x. The different function, that is DIFF function, differentiate an expression or a function. Its first argument is expression or function, and second argument is the independent variable. We have already tried an expression, now let's try a function. So type f is equal to exp within brackets x caret 2 plus arc sine within bracket x. Then type DIFF within brackets f of x comma x. To get a higher order differential, we need to add an extra third argument for order. So you can type DIFF then within brackets f of x comma 3. In this case, it is 3. Just like differentiation of expression, you can also integrate them. X is equal to VAR within bracket single quote x, that is x is equal to var within bracket single quotes x. Then in next line, x is equal to integral within brackets 1 by within another bracket 1 plus tan x star star 2 comma x. Then type S. Many times we need to find factors of an expression. We can use the factor function. So you can type it as y is equal to x caret 100 minus x caret 70 star cos x caret 2 plus cos x caret 2 star tan x caret 2. Then in the next line you can type f is equal to factor within brackets y. One can simplify complicated expression by using the function simplify. So you can type f dot simplify underscore full within brackets, empty brackets, for doing that. This simplifies the expression fully. We can also do simplification of just the algebraic part and trigonometric part. So for that you can type f dot simplify underscore ext then f dot simplify underscore trig then bracket. One can also find root of an equation by using find underscore root function. So for that you have to type phi is equal to var within brackets in single quotes phi. Then next line you have to type find underscore root within brackets cos within brackets phi, then is equal to sine within brackets phi, and comma 0 comma pi by 2. Then let us substitute the solution into the equation and see whether we are correct. So you can type VAR within brackets PHI in single quotes, then type F within brackets PHI is equal to cos PHI minus sin PHI, root is equal to find underscore root, then within brackets f of PHI is equal to 0 comma pi by 2. Then f dot substitute within brackets phi is equal to root. As we can see, we substitute the value, the correct is answer is equal to 0. Shown the solution we got was correct. Pause the video here and try out the following exercise and resume the video. Differentiate the following. First one, sin x square x cube x raised to 3 plus log 3x comma degree is equal to 2. Then second one, x caret 5 star log x raised to 7 to the 4th order. Then integrate the given expression sin x square plus ext into x raised to 3. Then find x, so that cos x square minus log x is equal to 0. Thus the equation have a root between 1 comma 2. So the solution is on your screen. So the first one you have to type VAR within brackets in single quotes x. The next line you have to type f of x is equal to x caret 5 star log in brackets x caret 7, and then diff within brackets f of x comma 5. After that the next line you have to type VAR. Second one you have to type VAR within brackets x. Then second line you have to type integral within brackets x star sine into x square comma x. Then for the third one you have to type VAR within brackets in single quote x. Then f is equal to cos into x caret 2 minus log of x. Then find underscore root within brackets f of x is equal to 0 comma 1 comma 2. So let us now try some matrix algebra symbolically. So type the VAR within brackets in single quotes A comma B comma C comma D. Next line you have to type A is equal to matrix within brackets in square brackets A comma 1 comma 0 comma another square bracket 0 comma B comma 0, then comma in another square bracket 0 comma C comma D, and next line you have to type A. Now let's do some matrix operation on this matrix. Type A dot det, then closing brackets, then A dot inverse, then again closing bracket. As we can see, we got the determinant and the inverse of the matrix respectively. So pause the video here, try out the following exercise and resume the video. Find the determinant and inverse of A is equal to within square brackets x comma 0 comma 1, then again another square bracket y comma 1 comma 0, and the third bracket z comma 0 comma y. The solution is on your screen. Here to type VAR within single quotes x comma y comma z, then A is equal to matrix within square brackets x comma 0 comma 1, then y comma 1 comma 0, then z comma 0 comma y, and third line you have to type A dot det and then brackets, and next one you have to type A dot inverse in brackets. So this brings us to the end of this tutorial. And in this tutorial we have learned to define symbolic expression and functions using the method var, then use built-in constants like pi, e, oo, and functions like sum, sin, cos, log, exp, and many more. Then use tab to see the documentation of a function. Do simple calculus using functions, that is diff to find a differential of a function, then integral to integrate an expression, then simplify to simplify the complicated expression, then substitute values in expressions using substitute function, then create symbolic matrices and perform operations on them like det to find out the determinant of a matrix and inverse to find out the inverse of a matrix. Here are some self-assessment questions for you to solve. How do you define a name y as a symbol? And second question, get the value of pi up to precision 5 digits using Sage. The third one, find third order differential function of f of x is equal to sin x caret 2 plus exp x caret 3. So the answers. We define a symbol using the function var. In this case it will be var within brackets y. That is the answer for the first one. Second one, the value of pi up to precision 5 digits is given as n within brackets pi comma 5. And the third question's answer is the third order differential function can be found out by adding the third argument which states the order. The syntax will be diff within brackets f of x comma 3. We hope you have enjoyed this tutorial and found it useful. Thank you.